Hey guys, this is Sanjay from FTC Team 7477, Super 7. Today, I'm going to be giving an in-depth explanation of binary search in Java. Binary search is a highly efficient algorithm to find an element in a sorted array. In this video, we'll break down the code and explain how binary search works step by step. Let's get started with the actual binary search method, right? So looking at the declaration, we have public static, which means it can be any element in it can be accessed anywhere. It also has two parameters: target, which is the value we're searching for in our array. To give you some context, binary search is essentially finding a given value in an array. So let's say I have an array of 2, 3, 4, and 5. Binary search just checks if a given number, let's say n, is in the array. So now let's move on to the actual code. Let me just code this quickly. Sorry, it has to be less than, not equal to, because we already did the same exact statement here. This is actually equals because single equals is used when actually initializing a variable. Sorry about that. Left equals mid plus 1 now. Right, so after all of this, so we are returning -1 if, alright, so let's start. This is the binary search method. It finds the index of a target element in a sorted array. If the element isn't found, it returns -1 as indicated by this statement over here. So the method uses three main variables: left, which points to the start of the current search range; right, which points to the end of the current search range; and mid, which represents the middle index of the range. Now let's see how it actually works. We start by setting left to 0, the beginning index of the array, because Java is 0 indexed. Same for right. We set right to array.length -1 because that is the index of the last element. These variables define the range of indices we are currently searching in. Initially, this range covers the entire array. Now, let's look at our main while loop. Binary search works by repeatedly dividing the search range in half. We use a while loop that runs as long as left is less than equal to right. Each iteration either finds a target element or reduces the range to search in, which shows how efficient and powerful binary search is compared to linear search. Inside the loop, the first step is to calculate the middle index of the range using int mid equals left plus right minus left divided by 2. This formula ensures that we avoid overflow when left and right are large numbers. For example, if left is 0 and right is 7, the midpoint will be 0 plus 7 over 2 equals 3. If you're wondering why it's not 3.5, it's because we didn't use any rounding, and Java automatically rounds it down. Like, it just truncates the decimal part of it. This mid index divides the array into two halves for comparison. Next, we compare the value of the mid index with the largest element. So this would be this, yeah, we would be talking about this line here. If array of mid is equal to the target, we found the element and we return the index mid. This is the best case scenario where the element we're trying to search is actually at the middle index of the array. If the target is not at mid, we need to decide whether to search the left half or the right half of the array. If array of mid is less than target, it means that the target must be in the right half. We just left to mid plus 1 as shown here to exclude the left half. If array of mid is greater than target, which we actually didn't have to do because we could just do an else statement which covers that, it means that the target must be in the left half, and we adjust right to mid minus 1. By doing this, we cut the search range in half with every iteration. So once the loop finishes, if the element isn't found, we return -1, which signifies that the target, which is this over here, target isn't in our sorted array. Now let's see our main method and binary search in action. So we have an array, right? So let's define target. Let's say we're trying to find the number 12, right? Obviously 12 isn't this array. So if our binary search program works, it should return -1. So now we call, so let's say int result equals, we call the binary search method with the parameters. So array target. So if result is not equal to -1, so we're searching if the result is found, right? So we use IntelliJ's built-in shortcut for system.out.println, and we can say the element found at index, right? And we can just return the index, which is just results. Now we can do else. So the other scenario is that it's not found. So we can just print out element not found. So let's run this with 12 and see what we get. We get element not found since 12 isn't in this array. Let's try changing, let me close this. Let's try changing target to something else in the array, like 3484, this number over here. Let's see if it works now. Element found at index 3. To make it cleaner, we could add a space between. Now let's run it. Element found at index 3 because counting from 0, 0, 1, 2, and 3. This shows that our binary search program works with all integer arrays and all targets. To summarize, binary search is a fast and efficient algorithm for finding elements in a sorted array. It works by repeatedly dividing the array in half and narrowing down the range of possible values for the target element, with a time complexity of O log n, which means that it's more efficient than some sorting algorithms. Let me just write it here, O log n. With a time complexity of O log n, binary search is much faster than linear search for large arrays. Thank you for watching this Super 7 programming tutorial, and make sure to be updated for more new programming content releases.